Hi guys, of second year, especially preparing for entry test. Second year, from second year, I have chosen exercise 1.4. I would like to solve teasers that frequently cause problem for students, even teachers, and I manage them to solve. I like to solve teasers. Simple question I don't like to solve. This first one will not give you concept, it is good one. Whenever you are asked find limit, right hand limit, left hand limit, function is continuous, discontinuous, domain, range, define, where function is defined, where function is not defined, just check three things. Always look for three things. Number one, denominator doesn't vanishes. Denominator does not vanish. Does not vanish means does not equal to 0. Number one, denominator doesn't vanish. Number two, square root never result in negative. Square root never result in negative. Means no negative value, overall negative value is allowed in square root. Number three, for base of log, a must be greater than 1. Positive as well as greater than 1. Positive as well as greater than 1. These are the three things you have to respect, you have to honor. Denominator never vanishes in case of limit, continuity, discontinuity, defined, not defined. Denominator doesn't vanish. Number one. Number two, square root never results in overall negative quantity because it is imaginary and we are dealing with a real valued function in calculus mostly. Real valued function in calculus at second year level. Third, log is defined for positive values and a must be greater than 1. A must be greater than, or base must be greater than 1. These are the three things you have to respect. Denominator never vanishes. Number one. Number two, square root doesn't result in negative because it is imaginary complex valued, and that is a property. Flaw or drawback of complex numbers, we cannot decide 2 iota is greater than or 2 iota is less than 3 iota. We can never tell this thing in complex numbers. Complex number. After taking their magnitude, then we are in a position to decide which one is greater or less. If we take the magnitude of this one, magnitude means positive. Magnitude means positive, real number. Whenever we have iota, we are not in a position to decide which one is smaller or which one is greater in case of complex number. This is the drawback of complex number. This is the drawback of complex number. You should be aware of that. Okay. Let me emphasize stress again. Denominator doesn't vanish in case of limit, continuity, discontinuity, defined, not defined. Square root never results in negative, and log a base must be greater than or equal to 1. You have to respect these three statements. Mark my words, if you are going to face any difficulty, I am responsible for that. Always stuck to definition, always cling to these three statements like a child to his or her mother. Okay, let me put across whatever I have said. Let me make a building on that. Number one is simple one. There is nothing, that is limit value, that is function. You just put x is equal to 1. It is our limit value, it is our function value, it is continuous everywhere. It is continuous everywhere. Look at this. Question number 2. We have f of x is equal to x square minus 9 over x minus 3. That is the beauty of mathematics. If we put x is equal to 3, it is undefined, but we can manage a value for that. Limit, when limit exists. When limit exists, let's see. When limit exists. When limit exists. Left hand limit. Left hand limit must be equal to right hand limit. Then we can say that limit exists. left hand limit is equal to right hand limit. Left hand limit is equal to right hand limit, then limit exists in that case. Limit exists in that case. So we have to check its continuity, discontinuity, limit exists at c is equal to 3. Okay. So our limit is x tends to 3. If I utilize positive sign here, it shows that x must be greater than 3. Means we are approaching to 3 from the right hand side. We are approaching to 3 from the right hand side on real line. On real line we are approaching from right hand side. What about left hand? This is our left hand limit. Okay, let me write here, and it must be less than 3. Means we are when x is less than 3, we are approaching towards 3 from the left, and right hand limit means x is greater than 3. We write limit x tends to 3. We are approaching to 3 from positive side. If both these values are equal, then limit exists. For existence of limit, left hand limit is equal to right hand limit. Left hand limit is equal to right hand limit. Left hand limit is equal to right hand limit. Look at this. We have given a single phase at x is equal to 3, means this qualifies for left hand limit as well as right hand limit. This qualifies for single function. There is no piece function. Left hand limit hasn't been separated. It is dual for both left hand limit as well as right hand limit. Means limit x tends to 3. We have x square minus 9 overall x minus 3. Mark my words. For direct limit x is 3 minus 3. Denominator doesn't vanish. We do not need 0 in the denominator. Number 1. Number 2, square root never results in negative, and log ax, a must be greater than 1. There is first situation. If I put x is equal to 3, then denominator is equal to 0. Then denominator is equal to 0. Then denominator is equal to 0. We have to get rid of this thing if possible, by factorizing, by rationalizing, by applying formula, whatever the case is. Here difference of 2 square situation prevails, and it's tiny one to calculate. Instead of 9, let me write 3 square. We have x minus 3. Factorize, it is x minus 3 times x plus 3 over x minus 3. Cancelled out. We have x plus 3, limit x tends to 3, means 3 plus 3 is equal to 6. So limit exists in that case, and limit value is 6, and limit value is 6. Limit value is 6. Limit exists because left and right hand limit, they are both bundled together in a single function. Limit exists. Limit exists. What about function value? Limit exists, but we are asked to find continuity as well. Left and right hand limit, it's okay. Means limit exists in that case. Limit exists in that case. X square minus 9, mark my words. In case of continuity, discontinuity, left hand limit, right hand limit, limit defined, not defined, denominator doesn't vanishes, square root never results in negative, and log ax, a must be greater than 1, greater than, even not equal to 1, greater than 1, exactly greater than 1. Okay, I have made one my point. We have to get rid of denominator 0. Second, look at this. There is a distinction between left and right hand limit in case of modulus function, absolute function, x minus 5. Check c is equal to 5. Means left hand limit, limit x tends to 5. Negative sign shows that we are moving, we are approaching towards 5 from the left hand side. From the left hand side means x less than 5, x less than 5. In that case, we take the mod as a negative, my x minus 5. Put limit, I have 5 minus 5, that's 0. What about right hand limit? This is left hand limit. What about right hand limit or HL? It means limit x tends to 5, introducing positive signs, means we are approaching towards 5 from the right hand side. We are approaching towards 5 from right hand side. In case of left hand limit, from left hand side. So we have to take modulus positive by definition. Less than means negative, greater than means positive. Put limit here, there is minus 5, x minus 5. Put 5, 5 minus 5, it's also equal to 0. Means left hand limit is equal to right hand limit. Limit exists at x is equal to 5. Limit exists at x is equal to 5. Limit exists at x is equal to 5. Left hand limit must be equal to right hand limit. Such type of function will give you good idea, good concept along with piecewise functions how to differentiate between left hand limit and right hand limit. Left hand limit and right hand limit. Left hand limit means we are approaching towards the given point from the left hand side, and the right hand limit shows that we are approaching towards the given point, given limit from the right hand side. Okay, cool. Let's come to continuity. To limit exists, for the existence of the limit, left hand limit must be equal to right hand limit. Existence of limit, left hand limit must be equal to right hand limit. For continuous function, for function to be continuous, we have left hand limit is equal to right hand limit, means limit exists as well as function value must be same. FV means function value. FV stands for function value. FV stands for function value. For existence of limit, we have left hand limit is equal to right hand limit, then limit exists. For continuity, left hand limit, right hand limit must be equal, means limit exists, as well as function value is also equal to limit value. Function value must also be equal to limit value. Let's see and find out how. Question number 1, discuss the continuity discontinuity at the given point. Here our limit is 2. Now let me give you a good idea about left hand limit, right hand limit and function value. Let's see and find out how to correct them, how to open them up. Left hand limit, function is f of x is equal to x plus 5 whenever if x is less than or equal to 2, is equal to 4x plus 1 if x is greater than 2. Now left hand limit, means at x is equal to limit x tends to introducing minus over to show that we are approaching from the left, x less than 2. Look, x, it is x greater than 2, it's less than or equal to 2. So our value from approaching from left, x is less than 2, lies here. So we have to take this value for the left hand limit, 2x plus 5. Okay, for right hand limit means limit x tends to 2, introducing positive signs, means x is greater than 2. For x is greater than 2 lies in that interval. We have to take this function 4x plus 1. So put limit 2 times 2 plus 5. 4 plus 5, it's 9. What about right hand limit? 4 times 2 plus 1, 8 plus 1, 9. Cool. So in that case, limit exists. What about function value? How to find function value? Function value at x is equal to, means exactly x is equal to lies where? Just look here. Less than or equal to. There is x less than 2 as well as x is equal to in that inequality. So for function value exactly at x is equal to, we have to take the same function 2x plus 5 because it has dual nature. Less than 2 it is function, equal to 2 also this is function. For function value we have to take 2x plus 5, putting 2 instead of x, 2 times 2 plus 5, that is 4 plus 5, we are going to get 9. Bingo! We have left hand limit 9, right hand limit 9, function value 9. 9 is equal to 9, left hand limit is equal to right hand limit, limit exists. Function value is same. Yes, function is continuous at x is equal to. Let me give you a good idea of this whole picture in a single line. Let me calculate all these three in a single line. Here is your how. That's left hand limit. Limit x tends to 2. It means x less than 2. Choose the interval, that is less than 2. 2x plus 5. What about right hand limit? Limit x tends to 2. Positive, it means greater than 2. Greater than 2 lies in that interval. We have 4x plus 1. What about function value? Function value means exactly at x is equal to. Exactly at x is equal to lies here in that interval. We have to take this 2x plus 5. Just put x is equal to, you will get 9. 9, this is also 9. So, left hand limit is equal to right hand limit is equal to function value. Yes, function is continuous at x is equal to. Moving in the same fashion towards next question, that is mine. 3x minus 1. We have to check continuity discontinuity at x is equal to 1. So the functions are, piecewise function is defined as 3x minus 1 if x is less than 1. It is for left hand limit. Is equal to 4 if x is equal to 1. X is equal to 1 means this is function value. Function value is given to us 4. What about right hand limit? It's 2x when x is greater than 1. Left hand limit. A limit x tends to 2. Introducing minus here. Yes, there is 1. At x is equal to 1. 1. Here it is 1. We have to check at x is equal to 1. X1. It means we have to check the interval. We have to choose the interval where x is less than 1. X less than 1 here. So we have to choose the corresponding function, that is 3x minus 1. That is my left hand limit. What about right hand limit? Limit x tends to 1. Introduce positive. It means x must be greater than 1. X is equal greater than 1 lies in that interval. Corresponding function is 2x. 2x. Put limit 3 times 1 minus 1. 3 minus 1 is 2. It is 2 times 1. It is 2. So, left hand limit is equal to right hand limit. Limit exists. Limit exists. What about function value? At x is equal to 1, we have given direct straightforward question without calculation, it is 4. So, our function value at x is equal to 1 is 4. So, in that case, only limit exists, but function value is different. So, it is not equal to function value, that is 4. Limit exists, left hand limit is equal to right hand limit, but function value is 4, limit value is 2. Function value is 4, limit value is 2. So, function is not continuous at x is equal to 1. Function is discontinuous at x is equal to 1. Discontinuous at x is equal to 1 in that case. Okay, moving towards next question. To give you clarity here, we have to check continuity discontinuity at x is equal to 2 and minus 2 both. 2 and minus 2 both. Let me manage for you as well. Calculus, base of calculus, piecewise functions. Beautiful, wonderful. Left hand limit for 2. Limit x tends to 2. Positive 2. Okay, I am taking positive 2. Introducing minus, it means x less than 2. Left hand limit. It is a left hand limit. To give you good idea, to paste definition on your mind. Left hand limit. It means less than 2. X less than 2 lies in that interval. Minus 2 is less than x is less than 2. So we have to take this interval x square minus 1. What about right hand limit? Right hand limit means limit x tends to 2 plus, it means x must be greater than 2. Choose the interval where x is greater than 2. Look at this. Here x is greater than 2. X is greater than 2. That is the corresponding value. Even it is direct given to us. So there is no variable how you can put value. Just survive here. This is our right hand limit. What about left hand limit? Put here x is equal to 2 square minus 1. 4 minus 1 is 3. So left hand limit is equal to right hand limit in that case. This is 3. This is also 3. Limit exists. What about function value? Exactly at x is equal to, what happens? Let's see. Exactly x is equal to lies in that interval. Greater than or equal to. Here for f of x is equal to 3 when x is greater than or equal to 2. If I open this up inequality, x is greater than 2 as well as x is equal to 2. It is dual inequality, greater or equal to, greater or equal to. So function value is also 3. Function value is also 3. F of 2 is also equal to 3. So left hand limit, right hand limit is equal to function value. All are 3. 3 is equal to 3 is equal to 3. So function is continuous at x is equal to. Function is continuous at x is equal to. Function is continuous. Function is continuous at x is equal to. What about minus 2? Let's see and find out. Now our limit point is x is equal to minus 2. Taking left and right hand limit according to x minus 2. Left hand limit, x tends to negative 2 from the left hand side. It means x must be less than minus 2. Less than minus 2 lies where? Minus 2 is less than x. Minus 2 is less than x. Minus 2 is less than x. Or x is less than or equal to minus 2. Where? Minus 2 is less than equal to x. Minus 2 less than or equal to x. Means x is greater than 2. We have to take left hand limit. We need x must be less than or equal to minus 2. That is the interval. X less than or equal to minus 2. Less than or equal to minus 2. So this is our 3x. Put instead of x minus 2, it will become minus 6. So our left hand limit is at x is equal to minus 2 is 6. What about right hand limit at x is equal to minus 2? Right hand limit, x tends to negative 2 from the positive side, means x must be greater than minus 2. X must be greater than minus 2. Look here, minus 2 less than x, minus 2 less than x, minus 2 less than x. It means x is greater than minus 2. Minus 2 is less than x. It can be written as x is greater than minus 2. So this is the right hand limit. So function, corresponding function is x square minus 1. X is minus 2. Minus 2 square minus 1. So it is 4 minus 1. Is 3. In that case, left hand limit does not equal to right hand limit. So there is no need to find function value. But let me calculate for you as well. Left hand limit does not equal to right hand limit in that case. So function is not continuous. But let me give you how to find on function value at x is equal to minus 2. Exactly minus 2. Look at this. Let me write this inequality. F of x is equal to minus f of x is equal to 3x, where x is less than or equal to minus 2. Minus 2. Look, x is minus 2 as well as x is equal to minus 2. Less than minus 2 equal to minus 2. Less than minus 2 equal to minus 2. Left hand limit as well as function value. So for function value, we take 3x. 3 times negative 2, it's negative 6. So left hand limit is minus 6. Right hand limit is 3 and this one is minus 6. If our right hand limit is negative 6, then the function would have been continuous at x is equal to minus 2. But in that case, limit doesn't exist. Left hand limit does not equal to right hand limit. If limit doesn't exist, so there is no need to check continuity. But for you, I have checked in at x is equal to minus 2, how to manage x is equal to minus 2 from this inequality. So function is continuous at x is equal to, but discontinuous at x is equal to minus 2. Okay, cool. Now these are tiny question to find mn, and the final question is the good one. To me, man of the match. Okay, let me compile this. I have given you good explanation. Now I show you how to crack them up. This is our function is f of x plus 2 when x is less than or equal to minus 1. It is c plus 2 when x is greater than minus 1. Now, what is this? Find c when limit exists. Find c when limit exists. When limit exists. When limit exists means left hand limit. Let me write left hand limit is equal to right hand limit. Left hand limit must be equal to right hand limit. In that case, we don't have to prove limit exists. It is given to us. If the limit exists, find the unknown. Means we have given left hand limit is equal to right hand limit. Here, what is function? It's minus 1 at minus 1. Limit x tends to minus 1. Approaching from left, x is minus 1. For minus 1, we have to choose this interval, x plus 2. equal to y, because it is given to us. Limit exists, find c. Right hand limit x tends to negative 1 from positive hand side, it means x is greater than minus 1. For greater than minus 1, that is the interval, that is c plus 2. Put limit here, minus 1 plus 2 is equal to c plus 2. It is 1 is equal to c plus 2. Solve for c. 1 minus 2 is equal to c. C is equal to minus 1. If limit exists, in that case, f of x plus 2 when x is less than or equal to minus 1, f of x is c plus 2 when x is greater than minus 1. When, if limit exists, then c is equal to minus 1. Then c is equal to minus 1. Then c is equal to minus 1. Look at this. Put x is equal to minus 1 here. Minus 1 plus 2, it's 1. If c is r minus 1, put here. Minus 1 plus 2, it is also 1. It's also 1. One can verify. Okay, moving towards next question. In next question, we are asked to find m and n. They are also same. Find the values of m and c when function is continuous. Now function is continuous, or function is f of x is equal to mx. If x is less than 3, cool, is equal to n if x is equal to 3, is equal to minus 2x plus n if x is greater than 3. Look at this. Less than 3 equal to 3 greater than 3 means we have to check our continuity at x is equal to 3. Not continuity. It is given to us function is continuous. Given to us function is continuous. Given to us function is continuous. Means left hand limit is equal to right hand limit is equal to function value. Left hand limit means x must be less than 3. For right hand limit, x is greater than 3. For function value, exactly x is equal to 3. X less than 3 lies where? Here. For this, we have to take mx. For right hand limit greater than 3, I have to take minus 2x plus n. For function value, exactly as x is equal to 3, I have n. Put x is equal to 3 here, it will become 3m. Minus 2 times 3 plus n is equal to n. 3m is equal to minus 6 plus 9 is equal to n. Minus 6 plus 9 is equal to m. Okay. So, we have, this is n. We have some conditions. 3m is equal to 3 is equal to n. From this, n is equal to 3, one can infer a is equal to b is equal to c. From this, n is equal to 3, taking these two, 3m is equal to 3, solving for m, it is equal to 3 over 3, means m is equal to 1. In that case, n is equal to 3, m is equal to 1. n is equal to 3, m is equal to 1. n is equal to 3, m is equal to 1. n is equal to 3, m is equal to 1. Look at this. What is m? m is 1. 3 times 1, minus 6 plus 9, 3, and n is 3. Look at this. Left hand limit is equal to right hand limit is equal to function value. Left hand limit is equal to right hand limit is equal to function value. They are all 3. They are all 3. Yes. So we have calculated the values of m and n when it is given to us the function is continuous at x is equal to 3. If function is continuous, then we have taken for granted that left hand limit is equal to right hand limit is equal to function value. I have written all these facts. Less than 3 means left hand limit. The corresponding value is mx. I have taken 3 times m because x is equal to 3. X is greater than 3, corresponding function is minus 2x plus 9. I have taken utilize x is equal to 3, that is 3. And exactly at x is equal to 3, function is n. I have written n. Then I have managed this is equal to 3m is equal to 3 is equal to from this n is equal to 3. 3m is equal to 3, from this m is equal to 1. So the values of m and n are, value of m is 1 and value of n is 3 when function is continuous at x is equal to 3. Moving towards second last question, a one liner for you, then final question. Shama Mahfil, let me say, at x is equal to 3, we have to check, find m. F of x means we have mx if x is less than 3. It is x square if x is greater than or equal to 3. Greater than or equal to 3. Okay, cool. Here, left hand limit is equal to right hand limit is equal to function value, because it is given to us function is continuous. Find the values of m and n so that the given function are continuous. Then we have to find m and n. Left hand limit means x must be less than 3. We have to take this function mx greater than 3. That is our function x square. For function value, look at it, greater than or equal to 3. X is greater than 3 or x is equal to 3. That is the corresponding at x is equal to 3 lies here. X is equal to 3 lies here exactly, and this is the corresponding function x square. Put x is equal to 3. M times 3 is equal to 3 square is equal to 3 square means 3m is equal to 9. So m is equal to 3. M is equal to 3. If function is continuous at x is equal to 3, our value of m is 3. Our value of m is 3. Last but not least, check the continuity of this function at x is equal to. If function is continuous at x is equal to continuous given to us, find k. Okay, let me make a space and solve this. Here x is equal to, that is our function value. This is function value, this is limit value. Limit means coming from left x is equal towards 2, from right towards 2, not exactly x is equal to. Limit value means we are approaching towards 2 but not exactly 2, towards 2, tending towards 2, approaching towards 2 but not exactly 2. So that is our corresponding limit function. Limit x tends to 2. So this is our function 2x plus 5 minus x plus 7. Because we have given a single part, we can manage. It is our left hand limit, it is our right hand limit, because there is only one piece. It is our left hand as well as right hand. It is compensation for both. It has dual nature. Okay. For direct limit x is equal to 2 minus 2, denominator vanishes. On the outside, I have delivered you a very lengthy speech. Denominator never be 0. Radical never be negative, and log is defined for greater than 1. Here x is equal to, in that case, apply binomial separate here, 2x plus 5 over 1 over 2, x plus 7, 1 over 2, expand or rationalize is the best strategy. That is the main symbol change, multiply as well as divide. 2x plus 5 plus x plus 7 over 2x plus 5 plus x plus 7. I know the reality of Hopital rule, but one can take this as an extra tool for tiny MCQs, entrance type examination. For subjective, you must have some quality. That is, change the symbol, multiply as well as divide. Whenever you rationalize, difference of two square situation props, always look at this. A minus b, that is our a plus b. So it is equal to a square minus b square. Here we have a, 2x plus 5. We have b, that is our x plus 7. Over x minus 2 times the bracket 2x plus 5 plus x plus 7. Square and root cancel, we have 2x plus 5 minus x plus 7 over x minus 2 times 2x plus 5 plus x plus 7. Okay, multiply minus throughout, we have 2x plus 5 minus x minus 7 over x minus 2, 2x plus 5 plus x plus 7. Calculate 2x minus x plus 5 minus 7, that's minus 2. So I am going to have same x minus 2, the troublemaker, that is about to be cancelled out throughout. Then we are in a position to put limit and got answer. Look at this, cancelled out. This one cancelled out. Can I move here or there? Here, good one. Now I have limit x tends to 2, 1 over 2x plus 5, x plus 7. There is denominator as well as square root. Check, put x is equal to 2 to the 4, 4 plus 5. Now it's good, no, not negative quantity. 2 plus 7, wonderful. 2 to the 4, 4 plus 5, it is 9. 2 to the 4, 4 plus 5 and 2 plus 9. 2 plus 7 is also 9. The square root of 9 is 3 plus 3. That is my limit value, 1 over 6. So limit value is 6. It is given to us, function is continuous at x is equal to, find k. Function is continuous means limit value is equal to function value. What is our limit value? That's our 1 upon 6. What is our function value? That's k. So this is the value of k. K is equal to 1 over 6. K is equal to 1 over 6. In that case, it's my tiny effort to you guys to solve teasers. I would like to kill teasers. I did not solve simple question. Let's solve by itself next.